Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay back with yet another geometry video for you guys, and today's lesson topic is all about vertical angle relationships. Now, before we reach to the inner core of this lesson and the whole topic of this lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as hitting that post notification bell to get notified on any of our latest posts at eCoreAcademy. Like I was saying, vertical angle relationships is the name of the topic for today. And as you look at the title of today's lesson, you might be looking at it thinking it's very daunting, very unfamiliar, something that's very complex. Well, this is a bit of a roadblock in geometry. The first third of geometry is very important to cover fundamentals, because fundamentals and basics, all these topics that are very easily comprehended, or topics that are already familiar, make up literally 1/3 of geometry, the entire course that we're going over, because you have to build a very strong foundation before you can actually exploit and move very quickly, very fast, and get lots of information in through the core of geometry, which is the other 2/3 of geometry. So now that we've basically almost breached that first third of our fundamentals in our geometry course, we're going to start to hit a roadblock here, starting with this lesson, and it's going to be all about vertical angle relationships. And I know it seems like a very specific lesson, like why is this so important? Well, this is where we start to move into the higher level thinking and the core of geometry, starting to drift away from the fundamentals, which you're already expected to know as of now, and you're already expected to have watched the previous videos if you're not understanding certain concepts in this video, and you're trying to move forward into geometry and moving on to more complex topics. Now, vertical angle relationships, this topic itself, this lesson, is a very short and very simple lesson, but it will get progressively more difficult from this point onwards, because this is a advanced class. It's an enrichment program as well, so we're trying to institute those difficulty levels and get you acquainted with that. So moving on to this specifics with this lesson, we're going to discover with vertical angle relationships, we're going to discover what exactly vertical angles are and what their different relationships are as well. So let's jump right into it. All right, so first slide is all about what are vertical angles. We're going to discover what vertical angles are, and we're going to look at the definition of vertical angles, so all about vertical angles as a whole. So the definition of vertical angles in geometry is basically two non-adjacent angles formed by intersecting lines. So if you think about the term vertical, that means up and down. It's not necessarily the same exact positioning for vertical angles in all cases, but when you do look at it at certain perspectives, angles are always going to be vertical from each other. So I'm going to show you a little diagram here. So this is line M and line L as represented by these symbols here, line M and line L. And basically they're intersecting at a common point, which is right here. And when they intersect, they're going to form different angles. And these angles are here labeled as these angles are already here labeled as, sorry about that. These angles are here labeled as 1, 2, 3, and 4. So those are the openings of the angles. And remember how our angles can be represented by certain specific symbols. So if you look at these angles 1, 2, 3, and 4, by the definition of vertical angles, they're two non-adjacent angles formed by intersecting lines. So now that we've already cleared the air about two intersecting lines, line M and line L, we see that they intersect and they create four different angles. So intersecting lines create four different angles at their intersected point. And if you look at this, we can see that angles 2 and angle 4. So I'm going to write this here. I'll write this over here. So 2 and 4 are a vertical angle pair, and 1 and 3 are a vertical angle pair. The reason being is, by the definition of an adjacent angle is basically an angle. Adjacent angles are two angles that share a same point and a common side. So examples of that would be, say for example, this line M here. So angle 2 and angle 3 would be adjacent because they share one common side and one common point here in the center. Same thing with angle 1 and angle 4, angle 1 and angle 2, and angle 4 and angle 3. So since those other pairs are not going to be are all adjacent, the only possible combination of non-adjacent pairs would be 2 and 4 and 3 and 1. So that's basically saying opposite angles. As you can see, 1 is on the direct opposite side of the point as 3, so they're a vertical angle pair, since they're not the only two non-adjacent pairs for each other in this case. And 2 and 4 are non-adjacent angles, as well as opposite angles, similarly to 1 and 3. And the reason they're named vertical angle is because if you're looking at it from this place, as this diagram shows, looking up and down, 2 and 4 are going to be vertical angles, meaning up and down opposite from each other. But if you were to rotate this 90 degrees, then 1 and 3 would also be a vertical pair, depending on your perspective. That's why vertical angles is going to be your accurate title for this concept. So let's move on. Vertical angles part 1, and we're going to look at the vertical angles theorem. So after looking at the definition of vertical angles, we can actually consolidate and prove a theorem. So that says that the vertical angles theorem states that if two angles form a pair of vertical angles, like I showed you here with 1 and 3 and 2 and 4, if they form a pair of vertical angles, then they must be congruent, meaning that two vertical angles must have the same exact measure in degrees. And the sides of one angle are the opposite rays to the other angle, meaning one side here is going to be the continuous ray in the opposite direction for each and every vertical angle pair. And I'm going to show you this here. So vertical angles theorem states that vertical angles, meaning 1 and 3 are vertical angles and 2 and 4 are vertical angles. That means that 1 must be congruent to 3. So I'm going to say 1 and 3 are congruent. Sorry, let's erase it here. Keep this nice and neat. So 1 and 3 are congruent. And 2 and 4 are also congruent, so are congruent. So that means they must have the same exact measure. That doesn't mean that say for example, that doesn't necessarily mean that angle 2 and 3 will have equal measures, but you're always guaranteed that 2 and 4 will have equal angle measures and 1 and 3 will have equal angle measures. But there's special cases in which all angles might have the same measure depending on the angle of intersection. So let's look at relationships developed by vertical angles. So the vertical angles theorem says that because angles 1 and 3, as well as 2 and 4, are vertical angles, they are congruent. That's basically representative of this example here. And this is always going to be true. So you can always substitute your value 1 and 3 for any specific situation that you're given, because this is a very generic diagram that I have here, which will apply for any pair of intersecting lines and vertical angles. So I suggest that you copy down this example here, take a screenshot of it, whatever you want to do. Just try and memorize this, because if you have this down, then all you can do is just apply this for any problem that you have without actually having to put too much process or too much identification thoughts into it. So vertical angles part 3, we're going to look at vertical angle qualifications. So for a vertical angle, for vertical angles, you must have Sorry about that. So for vertical angles, there must be a full intersection of lines for them to be opposite, for there to be opposite. Sorry, that's supposed to be there must be a full intersection of lines for there to be opposite angles that are vertical angles, meaning that you cannot have, a partial intersection at one point, which is basically like this. So an example of non-full intersection, meaning let's look at, sorry about that. So let's look at exactly what a full intersection of lines is. That's when two lines intersect at one common point and they fully go in opposite directions after intersecting. So that would be something like this, like our diagram here. So it's going to be like this. This is an example of full intersecting lines. They go in complete opposite directions and they're adjacent. They form that definite adjacence. An example of non-full intersections of lines is a ray coming from a focal point that does not make vertical angles. So what that's basically saying is, if you take one line and then you take a partial intersection here, like a ray, which extends out from one point and extends out like this, you're not given your other side here. There's nothing here. So that makes this not fit, so not full intersection. Therefore, it cannot be determined as, you cannot determine vertical angle pairs because of that. So that's just simple qualifications. Not full intersection. So vertical angles part 4, let's look at vertical angles as proof. So when using the vertical angles theorem for vertical angles, you can use proof. You can use it as proof, and your proof can be less formal. Like I said, you can use certain properties or definitions or even theorems. So in this case, vertical angles theorem is very popular because of the fact that it can be used as proof, supporting any form of the vertical angles by the definition and any two intersecting lines. So you can use the vertical angle theorem for vertical angles, and your proof can be less formal, meaning if you're saying that, because B and C form a vertical angle pair, that means that they must be congruent, and since that's part of the vertical angles theorem. You can merely just say the vertical angles theorem as part of your proof, which is going to be less formal. It's informal. And as long as each reason and statement follows the previous one, it is deemed accurate, meaning you have to have chronological order in your process when proving vertical angles, and it'll be correct because you can be very simplistic and everything is already assumed in that process. So it's a very simple process there. And we're going to look at important concepts for vertical angles part 5. And some important concepts are that when two lines are perpendicular, meaning when two lines intersect at a 90-degree angle, so I'll just draw that out here for you. Two lines form a 90-degree angle. This when they intersect. So when they're perpendicular, that means two lines will form a 90-degree angle. Like say, for example, here, that means all four angles will be equivalent. And that means all four angles must be 90-degree angles. And that comes to our second point, saying that the sum of both pairs of vertical angles, meaning all the angles formed by intersecting lines, is going to be 360 degrees. So it's going to say, I'm going to say here, 4 90-degree angle pairs. If it's perpendicular, that's only if it's perpendicular. 4 90-degree angles, which equals 360 degrees as its total. Now let's look at the applications of vertical angles in some examples here. So we're going to practice with the equations in this example here. So we're going to discover what the value of x is in this diagram over here. So we're given two angles, and as you can see here, they're obviously going to be vertical angles since they're non-adjacent and opposite angles. And since what we know about the vertical angles theorem, we know that vertical angles are always going to be congruent. So we can say that 5x, or congruent, meaning they're also equivalent. So we can say that 5x is going to be congruent or equivalent to 2x plus 24. And now we're just going to solve this just as a regular algebraic equation. So we're going to isolate the variable on one side. We're gonna move all of the combine like terms, move all of these x values to one side and leave our constant on the other side. So we're going to get that 3x equals 24 after subtracting 2x from both sides of the equation. And now we're going to divide each side by 3 to isolate the variable, and we get that x equals 8. So that's the answer for our problem, x equals 8. So just make sure you always refer back to the question to see if you've answered everything. And yes, indeed, we have x equals 8. For our final side here, final problem, it's going to be applications of vertical angles. So this is going to be more of the proofs. We're going to use this practice with 2-column proofs here. So I'm going to draw my 2-column proof, and we're going to put statements on my left side and reasons on my right side. I always keep this consistent no matter what problem I'm doing because it helps me keep myself organized and more routine with every problem that I come across. So what we're given here is that angles A and B are vertical angles, and that's part of the problem. So we're going to write here as our statement that it's a given statement, given as a problem or given as a statement, as information. And we're going to state that A equals B. Sorry about that. So we're going to state that A equals B. And what we know from that is that since they are vertical angles, we know that here A equals B because of the vertical angles theorem, because we know that the vertical angles theorem proves that vertical angles are going to be equivalent or congruent. And all this is saying here is that angle A is congruent to angle B, and that's just by the angle congruence. Explain that. So the angle congruence postulate. All right, guys, I hope you enjoyed this video. This was eCoreAcademy e-learning platform today. Please make sure to like and subscribe down below and hit that post notification bell to get notified on any of our channel's latest posts. Please make sure to visit our website at eCoreAcademy.org if you want to get full unlocked access to integrated quizzes, note sheets, and worksheets that go along with each and every single one of our videos, and it's organized into course studies. Feel free to email us at eCoreAcademy@gmail.com. That'll be in the link in the description as well if you want to visit that, if you want to ask us any questions, or if you just want to reach out to us. And visit all of our socials in the description box below, which is at Facebook, Instagram, and Twitter, if you want to see what content we have there, and if you want to share our videos and see through to it if anyone else needs help with these finding these videos. So I hope you guys enjoyed. This has been AJ Raj, and I will see you guys in the next one. Peace.